Hey everybody, let's talk about chemical formulas. Unfortunately for some of you, chemical formulas involve a little bit of math. So just like any math, some of you are going to pick up on the pattern really quick and you're going to think this is a very easy lesson. Some of you, it's going to take you a little bit longer and you're going to need more practice, and that's okay. So you need to be really honest with yourself so that you know how much practice you need to be able to understand chemical formulas and how they work. Your essential question for today is, how are compounds represented? We're going to talk about a couple different models you can use to show compounds and molecules. Let's go back to chemical symbols. We talked about chemical symbols with the periodic table, and they're all over the periodic table. We talked about how every single element has its own unique chemical symbol, and the chemical symbol is either 1 or 2 letters. The first letter is always capitalized no matter what. The second letter, if there is a second letter, is always lowercase. It's very, very important that you capitalize and lowercase correctly. Here are some examples. You don't need to write these down, but I'm just showing you a whole bunch of options for everything that starts with C. So it's really important that the second letter is lowercase so that I know that CD stands for cadmium and Cl stands for chlorine. Notice cobalt over here. Cobalt is CO. The lowercase o is so important because if that were a capital O, then I would not have cobalt anymore. I would have a compound of carbon and oxygen, and I would make carbon monoxide instead of cobalt. So it's very important that when you're writing and reading elements, you're paying attention to those chemical symbols and which ones are capital and which ones lowercase. So a chemical formula is very simply a list of chemical symbols and little bitty numbers. And all of those symbols and numbers tell me how many elements and atoms are in each molecule of that compound. These are all chemical formulas. FeO tells me that that is a compound of iron and oxygen. C6H12O6 is glucose, and that tells me it involves carbon, hydrogen, and oxygen. By the way, some molecules you may want to try to remember a little bit would be these over here. All of these are involved in photosynthesis, and so test makers love to include these because of the photosynthesis connection. So there were little numbers behind carbon, hydrogen, and oxygen. Those little numbers are called subscripts. And if I break down the word subscript into 2 pieces, sub means under, like submarine, and then script means writing. So it is literally the little writing after the element. It tells me how many atoms of that element are there in the compound. It is always, always, always written after the element. It is not before. Here are some examples. First one's copper sulfate. I have copper, sulfur, and oxygen. Notice behind copper and sulfur, there's no little numbers. There's an imaginary 1 if there's no number there. So copper, 1 atom of copper, sulfur, 1 atom of sulfur, and 4 atoms of oxygen. If I look across here at glucose, remember I told glucose is important, I have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen in every single molecule of a compound of glucose. You can take a minute and look at some of the other words. Zinc chloride. I have 1 zinc, 2 chlorines. That's the basics of chemical formulas. Every now and then you'll get a little more complicated of a formula. So let's talk about complication number 1. Complication number 1 is a coefficient. Just like in math class, a coefficient is a big number in front that you use to multiply everything after it. The coefficient basically means in chemistry, I have that many molecules of the compound there. So I used the exact same molecules I just had a second ago, copper sulfate, but now I have a 2 in front of it. So that means instead of just copper sulfate, I have 2 molecules of copper sulfate there. If I were going to say how many total atoms of copper are there in this example, I would have to say 2 copper atoms because I have 1 plus 1, 2 total. I would multiply to make it a little bit faster and distribute my 2 amongst all of my atoms. So 2 copper, 2 sulfur, and then with oxygen I had 4, so 4 times 2 equals 8. Now I have 8 total oxygen. Let's look at zinc chloride. 3. I multiply everything behind it by 3. I started with 1 zinc, so 1 times 3, 3 total zincs. I started with 2 chlorines, so 2 times 3, now I have 6 total chlorines. I could also write this by saying zinc chloride and zinc chloride and zinc chloride. I have 3 of them. Sometimes, complication number 2, you'll have a parentheses involved. I'm going to use a math term. Are you ready? You have to use the distributive property in order to multiply everything inside the parentheses by the subscript outside the parentheses. Let's look at a couple examples. So I have aluminum sulfate here. Notice the parentheses. Notice aluminum is not in the parentheses. So this little 3 out here, aluminum does not care about that little 3 because aluminum's not in the parentheses. So if I want to know how many aluminum atoms there are, my answer is 2. But if I want to find out sulfur or oxygen, now we have a complication because sulfur and oxygen are in the parentheses. So I need to do something with this 3 outside the parentheses. I need to do the distributive property. I have 1 sulfur, but there's a 3 outside the parentheses, so I have to multiply it by 3. There are 3 total sulfur atoms in this compound. Inside the parentheses, I have 4 oxygen. But outside the parentheses, I have a 3. So I have to do 3 times 4 to say there are 12 total oxygen atoms. So in total, I have 2 aluminum, 3 sulfur, and 12 oxygen atoms and aluminum sulfate. Let's try another example with this molecule that has barium, carbon, and nitrogen. Barium is outside of the parentheses. So barium just has 1 atom. Because there's no number, and remember there's an imaginary 1 right there. See the imaginary 1? No, you don't. It's imaginary. Carbon and nitrogen inside the parentheses also have imaginary 1s. There is just 1 carbon and 1 nitrogen inside the parentheses. But notice there are 2, a subscript of a 2, outside the parentheses. So that means I have 2 sets of carbon-nitrogen. I'm going to take that 2, multiply it by carbon, multiply it by nitrogen. So 2 times 1 is 2. I have 2 carbons and 2 nitrogens. In total, 1 barium, 2 carbon, 2 nitrogen. Sometimes on a test, you'll get a question that has how many total elements are there in the compound. Whenever you are counting elements, you are literally just counting capital letters because every element symbol has a capital letter. So in the first one, I have CaCO3. Calcium is 1, carbon's another one, oxygen's another one, I have 3 total elements. Number 2, I have carbon, hydrogen, oxygen. 3 total elements. Next, we're going to count the atoms of each element in the compounds. So the first one, C12H22O11. I have 3 elements, carbon, hydrogen, oxygen. I have 12 carbons, 22 hydrogen atoms, and 11 oxygen atoms. If I had a test question that asked me how many total atoms there are, I would have to add all of that up. So 12 plus 22 plus 11 is equal to 45 total atoms. Sometimes you'll get a question that says something like, how many total hydrogens are there? So if you looked at number 2 and had a question that said, how many hydrogens are in this compound? It's very easy. You would say 12. 12 hydrogens in the compound. Number 4 is a little tricky. I have hydrogen and oxygen listed twice. Now, hydrogen is still the element hydrogen. It doesn't matter how many times I list it. So in number 4, there's still only 3 elements. I have 6 atoms of carbon. But what do I do about hydrogen and oxygen? First of all, I have my parentheses. So I'm going to have to distribute this 3 between the O and the H only on the inside, not the 7 and the 2. They're outside the parentheses. So inside the parentheses, I now have 3 oxygen and 3 hydrogen. Well, if I have 3 hydrogen inside the parentheses and 7 hydrogen outside the parentheses, how many total hydrogens do I have? I have a total of 10. And if I have 3 oxygens inside the parentheses and 2 outside the parentheses, how many total? I would add them up to get 5. So in this compound, I have 3 elements, carbon, hydrogen, oxygen, with 6 carbon, 10 hydrogen, and 5 oxygen. In summary, compounds and molecules are represented by chemical formulas, and the chemical formulas are letters and numbers that show how many atoms are in each compound or molecule. The subscript is the little number behind the element, and that tells us how many atoms of each element are there. If there is no subscript, that's an imaginary 1. And if you need to write in your imaginary 1s whenever you're doing a test or a question, do that. There's no shame in writing in your imaginary 1s. You need to use the distributive property if any of those compounds get a little complicated. If there's a big number in front, that's the coefficient. And I'm going to distribute that coefficient with everything behind it in the compound. If I have a parentheses, there should be a little subscript outside the parentheses. That means I'm going to distribute that little subscript to everything inside the parentheses. But if it's outside the parentheses, it does not care about the little subscript there. Make sure you practice. It is so much easier to understand if you are drawing pictures of them, modeling with Play-Doh or clay or pieces of paper or beans or something like that, and you're practicing your counting. You need to practice however much you need to practice in order to get your questions right.